Probably also heard the term by now in Azure around resource groups, and this is one of the major strengths, in my opinion, of Azure, the way they go about
probably also heard the term by
resources.
now
Azure.
Well, for one, if we look at
the resource group, and it's indicated by this icon on the top left of the box here, and inside a resource group is essentially where we put our different services. So these could be virtual machines, could be Azure SQL database, could be a web app, could be storage accounts, whatever we decide we want to go in there. And essentially it's a container that we put everything in, and we can control security there, but it's also a nice grouping of resources together. And the reason I say this is because when you go ahead and destroy a resource group, you can basically destroy everything inside of there. So this makes you think about, how do you plan out your resource groups? What's the appropriate time to create a new one? It's okay to have lots and lots of resource groups. I think people get a little over concerned about sprawl, but if you've got a good organization strategy around your resource groups, then it's not a big deal. Typically, everything that shares the same application boundary, so if an application lifecycle is the same, you would group that together in the same resource group. You wouldn't typically group, say, your shared services like network infrastructure, Active Directory servers in the same resource group as a new application you're deploying. That new application would go in its own resource group, and shared services would go in one. But again, very, very easy way to organize things. So if we look at why resource groups, well, one, I said organization. The other one is that easy deprovisioning. So again, we don't want to go through every object one at a time and destroy it. Like, we don't want to have to go through and delete every VM, every storage account, everything associated with that app. It's helpful just to be able to say, yep, deleting that entire deployment of resources there. It is a security boundary for role-based access control. So again, we can give people rights at the resource group level. We can give them rights at the subscription level for Azure. But if, say, we have an application team, we just want to give them access to their application in the Azure portal, we can do that through RBAC at the resource group level. And last but not least are Azure policies that we can apply as well, which is to say, hey, in this resource group, you can only deploy workloads of X size. And if you try to do it, even though you have the rights to do it, it will stop you. And you'll definitely learn more about RBAC and policies as you go through. In this demonstration, we're now going to take a look at resource groups, something we keep coming back to over and over again, and tagging of those resource groups. So let's head over to the Azure portal. And in the Azure portal, we'll go straight over to resource groups on the left-hand side. And you can see I've got a couple of resource groups already there in a variety of locations. And I'm going to go ahead and just simply add a new one. So I click add. And in the basics here, the first thing I need to do is choose my subscription, where I'm going to put that resource group, and then give that resource group a name. So I'll call this one AZ Exam Demo. Then I choose the region. Now, you can put objects in the resource group from other regions. The purpose of the region for the resource group is where the metadata for that resource group is actually stored, all the details about it, the tags, etc. It ultimately still has to be stored somewhere, and so that's the purpose of this region here. So it doesn't really matter too much where you put it, but the one benefit is when you are using ARM templates later on and saying, okay, I want to deploy this virtual machine, and asks you for the region to deploy the virtual machine in, you can simply state inherit from resource group. So it does still help to put the resource groups in the same region if you have a primary region where you deploy your workloads to. Following on from the basics, we then hit tags, and right away we can simply input tags directly on our resource groups as well. So you may have seen in some of the subscription demos, we can put tags there, but we can also put tags directly on the resource groups. And there was that tagging spreadsheet that we covered in one of the earlier modules. That's a good thing to kind of, set your stage in terms of what tags you want to keep and how you're going to tag. Think about that first before you just go in here and start tagging. But when you are ready and you've come up with the tags that you want, certainly through automation, you could deploy these much more easily. But if you need to do them in the portal, things like cost center are very common. I'll just put cost center. Lab could be my cost center, could be the HR department, could be, depends on your specific situation. And then you might have other things like maintenance window is a common one. I could say, this is going to be Saturday 9 p.m. It could be a maintenance window that I have, and you might have different ways of storing these, even JSON templates in some cases. But it's very important to make sure that you tag everything that you build so that you know who built it, what it's for, who's paying for it, etc. Business owner and technical owner, if nothing else, knowing who the machines and other services that are in there belong to is so important when it comes to reporting on cost, etc. So if we go ahead and click review and create, and then click create, and that will go ahead and create our resource group, which only takes a second or two, and then we can immediately go into that resource group. So here we are in AZ exam demo, and I want to bring your attention to a few things. One, we have an activity log in here, so this will show you one update right now. If we refresh, we see the update resource group, and that's the first activity log update from any new resource group that gets created. We have an access control section, so we can assign permissions. We cover RBAC permissions in identity, but we can add role assignments directly to the resource group. So think of this as another boundary for given access. Perhaps we don't want to give subscription access or any role in the subscription to somebody, but we just want to give them access to certain resources that we put in the resource group. This is the place we can do that. Tags we already discussed, and again, you can create them when you build your resource group, and also add and modify tags as you go. Events are a way to trigger and are more associated with things like logic apps, event grid, etc. Not something we need to cover right now. If we go down, there are a few other quick things to be aware of. Resource costs. This is a great area because if we've got lots of resources in our group, again, right now, empty resource groups, it's not showing really anything there, but as resources get put in the resource group, this is a place where you can see the roll up of those costs as well. We then have something that is really important, and you may get asked questions on the exam for this, is deployments, and we do cover ARM templates later on as well, but essentially you can go back here and look at all the deployments that have occurred in that resource group. So every time whether you deploy from the portal, whether you deploy from an ARM template, you can see those deployments, you can view the templates, you can redeploy them, and you'll see more about that later on. Next we have policies, and policies are very much the same as the policies we can apply to subscription. So if you remember from the very first section of the course, we did subscription policies. Same thing here, we can assign a policy or a group of policies via an initiative. Maybe this resource group, we're restricting the virtual machine instance SKUs that are allowed to be provisioned. Maybe we want to enforce some type of encryption. Those are things you can then do directly on the resource group. And if we go back, a few other quick things. One is automation script, and this is also where you can just download the template for all the resources that are actually in there right now. So deployments were showing you previous deployments. Automation script is really just downloading that resource group as an ARM template. Moving further on, we have a lot of options to jump ahead in monitoring. So we can get to monitoring through Azure Monitor, so we can access that through services, as you may have seen in the monitoring piece of the course as well, but we can also access it directly from here as well. And last but not least, we do have a new support request option we can submit directly from the resource group as well. But with that, that's really all you need to know for resource groups. Hopefully this gets you up and running. Just be aware of what you can and can't do directly from the resource group area. Common things to look out for are the deployments, the policies you can apply to resource groups, and just knowing that you can assign RBAC roles directly to a resource group as a way to restrict permissions in case you get questions around user scenarios and things like that on your exam. And with that concludes this demonstration. Just like with resource groups, you may have already heard the term ARM templates, or Azure Resource Manager. ARM essentially stands for just that, Azure Resource Manager, and this is essentially the way Microsoft thinks about their resources, their structure, how they make them available to you, and how you can interact with them. So we'll break down the major components here. Well, one, we have our resource. A resource is an individual manageable item that's available to you in Microsoft Azure. Then we have resource groups, which we already covered. That's the container where you can house your resources for management. Then we have the resource provider. So this is what provides the resources that we can deploy in Azure. So Microsoft uses these terms like Microsoft.compute, Microsoft.storage, etc. And that's essentially the provider in Azure that is surfacing up the resources to you. And then we have the concept of ARM templates, where we can basically define all of the resources we want to deploy into a resource group in what's called an ARM template, and that's just like a definition file as code. If we look at that a little bit more detail, this is what an ARM template looks like. You see on the black screenshot there, it's essentially a way to just define the resources, the variables, parameters. It's got a schema and it's got a language that you need to understand, but the code there, not that it's very important for the purposes right now, but essentially is defining a storage account with local replication. That's just defined in code and then can be deployed. And you'll learn this construct of infrastructure as code, also known as IAC. You can download templates from the Azure portal, you can author new templates, and you can use quick start templates provided by Microsoft. As a good example, there's two links here. You can access the quick start templates on azure.microsoft.com or on GitHub as well. They're both available to you there, and there's hundreds and hundreds of them available. So if you're looking for a quick way to get a service up and running, odds are somebody already has a template created for it. Inside the ARM template, or the way you go about deploying ARM templates, there are multiple file types associated with them. One, we have the ARM template file itself. This describes the configuration of your infrastructure as code via a JSON file. You have an ARM template parameters file. So what this means is you can define everything in your ARM template, but there might be variable parameters that you want to include, and that's what the parameter file basically does. You separate your parameters out, and then you have deployment scripts as well. Example, PowerShell for deployment that you could use to say, go ahead and deploy this ARM template, or you could deploy them from the Azure portal directly if you wanted to as well. In addition, if we break down the ARM template itself now into its construct, so when you look at the code in an ARM template, you'll find that it has parameters in the template itself. So these define the inputs you want to pass into the ARM template during its deployment, and that can be passed in through that parameters file if you want to include that separately. You have variables that can be used throughout your template. Instead of recreating everything, you can just simplify your template by creating reuse of values. Resources define the resources you wish to deploy or update. And then we have outputs. Anything returned after the ARM template deploys are outputs. So essentially, just to bring this back to Azure Resource Manager again, we've got resource groups. We want to deploy resources in them. We can create an ARM template file that defines all those resources. If we want to, we can have optional parameters and variables that we use to simplify the reuse of that file. But essentially, then we can go ahead and say, hey, I want to deploy this ARM template. It's going to deploy all the resources indicated in the ARM template into that resource group, and then we'll return any outputs, like any information we need back from the deployment that maybe we were going to use in subsequent workflows would be returned to us. Right, with all those intros out of the way, let's dive straight into the meat now. And let's just take an introduction to virtual machines. For anybody that's not familiar with virtual machines, it helps to just think about how your computer operates, right? So you have some hardware, you have CPU, memory, and disk. And on top of that, you have your operating system. So this could be Microsoft Windows, could be Mac OS. And on top of that, we obviously have our applications that we install. Well, along came virtualization many years ago now, and the concept is still very similar. We still have our hardware, so we still have to run our applications somewhere, and we have our CPU, memory, and disk, but we install something in between, which is the hypervisor, and on top of the hypervisor can live multiple operating systems with multiple applications. So instead of just running one operating system that may only get used 10% of the time, we can run multiple operating systems, make much more use out of that CPU, memory, and disk. And every single one of these is essentially our virtual machine. And when we're in Azure, we're basically doing the same thing. We don't manage the hypervisor on premises. You would typically manage something like VMware ESXi or Microsoft Hyper-V. But in the public cloud, Microsoft presents us with a whole bunch of options for provisioning our virtual machines. And that leads us onto a really, really cool thing, which is all of the VM types available to us. Typically on premises, we would have one or maybe two different variations of hosts, and every time Intel releases a new CPU, we would upgrade those hosts. But in the public cloud, because just the scale that they have, you have multiple choices available to you. So if we go through these, it's very important to understand and select the right instance type for your workload. The A series were the very first series that Microsoft introduced. They're divided up into basic and standard. So standard are actually our general purpose VMs, and then there's a basic version of the A series for testing and development. Then we get on to B, which I remember as B for burstable. These instances can burst to the full capacity of the CPU when needed, but you get a discount because you're not using the machine a lot of the time, so it's storing CPU credits, and then when it has to consume CPU, it can use those credits and use the full capacity of the CPU. Now, if you're going to use the CPU continuously, it's obviously not going to make sense because you're not going to store any credits and you're going to get worse performance, but a very cost-effective option there, and I highly encourage people to use them during some of the labs and things as well. D is the general purpose ones. You'll see a lot of these around in the enterprise. And then we have memory optimized. These are the E series. You'll see there's some other memory optimized ones out there. This is the newest memory optimized series they brought out recently. This is a high memory to CPU core ratio. Then we go into the F series immediately after memory optimized is CPU optimized, and this is the reverse. So we have a high CPU core to memory ratio, and so it's kind of the opposite of the E series there. The G series, Microsoft calls this the Godzilla, or at least that's what people tell me when I'm walking around, Microsoft Ignite in various conferences. Very large instances, hence the Godzilla name there for large databases, big data use cases. Then we got high performance compute, computational, molecular modeling, scientific applications. That's the H series. The L series is for storage. I remember this as L for LUN, like in the traditional sense of storage. And these are, storage optimized with a high disk throughput and high I/O. Then we got the M series, another very large memory series available. These go actually much, much larger than the E series. You can go up to 3.5 terabytes of RAM here. Then we have the N series. They're actually divided up into NV and NC, depending on the type you choose there and what configuration you require. But these are graphics card enabled instances. And finally, we have SAP HANA on Azure certified instances as well. So as you can see, just a ton to choose from that. And then we go into the specialization. So if you just got your head around, okay, I've got all these types, well, now there's different specializations, and you notice this in the way the instance types are written out. So for example, we've got S for premium storage. So if you see D series, you'll also see a DS version. So DSV2, that's a premium storage option there. We have the M specialization as well. That's for larger memory of a configuration type. So if, for example, we've got a standard A2, then you might see a standard A2M that just has more memory. And then the final one, we have R, which is supports remote direct memory access, also known as RDMA, and you'll see that by things like H16MR as well. In this demonstration, we're going to look at creating a virtual machine from the Azure portal. So let's head over there to begin. And here we are in the Azure portal, and one of the things you might notice if you have built virtual machines before is things have changed a little bit over time, and Microsoft continues to change this part of the portal. But we can go ahead now and click virtual machines and see I've already got one virtual machine there. That's just a Linux virtual machine I've got running. I'm going to add another one. We're going to build a Windows virtual machine at this point. So I'm going to click Add. And straight away now you get the Create a Virtual Machine panel that pops up, and you'll see they've added these tabs now across the top to make it easier to go forward, come back, throughout the process in itself. If we go through though, click Subscription, you would choose your subscription that you want to provision this virtual machine into, and then choose the resource group that you want to use. Now I've already got a resource group created called AZ-Demo where VM01 is currently in, but I'm going to add another VM to that resource group, so we'll continue to use AZ-Demo. I now need to give it a virtual machine name, so in my case I'm just going to call this VM Demo 01, and now I need to choose the region, so I can choose any of the Azure regions that I'm entitled to provision into. In my case I'm going to choose East US, and next we have the availability options. Now if I click this, you will see that sometimes we will get availability zone, sometimes we will get availability sets. So availability sets were covered in one of the lectures, and if you haven't jumped to that yet, feel free to jump ahead to availability sets. Availability sets are inside the same data center, but allows you to have two virtual machines in separate racks of power and network connectivity. Availability zones are in the same region, but they're in separate data centers in themselves. So it's another way to get additional redundancy. Now Microsoft is rolling these out gradually to all the regions. If you click this icon, it's blurred out a little bit there, but you can click the little blue thing that says view locations that support availability zones, and then you can choose those. But definitely encourage you to understand the differences between availability sets and availability zones, because Microsoft is really emphasizing availability zones going forward. Next, we choose the image. So I'm going to choose from a Windows or Linux image here. These are all the standard ones available to you, and I can choose Windows Server 2016 directly from this pane. Now note, if I wanted to see all the images, I can click Browse All Images and Disks. That will show me everything available to me from my marketplace, but in my case, I'm just going to do a 2016 data center server. Next, we move on to the size, so I can click Change Size here. And this will give me all the different VM sizing options available to me, and I can do various filters on these. I can get rid of these filters if I want to. I can add additional filters. Right now it's looking at general purpose with premium disk supported, small sizes right now, so that's why I'm only getting a handful right there. If I got rid of the small, it's going to certainly open it up to a lot more sizes that are available to me. And in some cases, your subscription may just not support that, or perhaps you've also got a policy in place that doesn't allow you to choose specific VM types. But in my case, I'm going to go back up and I'm going to choose one of the B1s. I'm going to choose the B1 MS. That option there, that's a 1 CPU, 2 gig of RAM, supports 2 data disks, got a max IOPS of 800, includes a temporary storage drive with 4 gig on it, and it's using premium disks. And on the right, I can see my cost per month would be $15.40 estimated. Now, one thing to note with the B series, as you probably heard about when we did the lecture on VM types, the B series does use the concept of CPU credits. So when you do provision them up, they can take a little bit longer to build. The purpose of B series is really for web servers, so that when they're not in use, they're generating credits. When they are in use, they're consuming from those credits, but you don't want to use them if you're running things at 100% all the time. However, they are very cheap to run for lab purposes. You've got like the B1S here, smaller memory version. You've got the B1MS, which is that double memory version of the B1. Much cheaper to run, for the purposes of your lab. But again, they take a little bit longer to provision. But if you select one, then go ahead and click Select, and then that takes you on to the next section. So now we need to include our administrator account. And you'll notice that things like admin aren't allowed. That's a restricted word. If I go back and I just type in, say, my name, that is allowed, and we can move forward with that. And then you can go ahead and type in your password. This is the Windows password to get into the machine. Once we've got all that typed in and the passwords match, we can then move on to the inbound port rules. And this section is pretty important, because if we want to RDP into the machine, say over the internet, we do need to expose that. So we can allow selected ports, and we can choose the ports that we want to expose. So perhaps RDP is one I want to expose. This is great that they added this. Things aren't just open by default. You have to choose to allow those inbound ports to be open, and you can further lock them down using Azure Security Center and just-in-time access as well. But for right now, just go ahead and select RDP if you do plan on connecting into the machine after you've deployed it, which you'll need for some of the subsequent demonstrations that we do. One thing to note is the one difference between Windows and Linux here is in Linux we could be prompted to generate a key and put that in here, or we could use a user account. Windows, we just use username and password for the administrator account. If we keep going down, the next thing we have is save money, which is save up to 49% if you already own an Azure license for that Windows server. So if you already have one, simply select yes and choose your license type. You have to confirm that you have software assurance for that, and that will reduce the cost that you pay for those Windows servers. So this is a great benefit. If you've got a lot of Windows machines that you move into Azure, you will get a cost benefit by already having that software assurance. But in my case, I don't, so I'm going to click no, and then move on to the next panel, which is the disk section. So here we have our disk types, and as you can see, this machine, because it is an S series, does support premium SSD as well as standard SSD and standard HDD as well. I'm going to just go ahead and choose premium SSD for my disks there, and then I can choose if I want to create and attach a new disk or attach an existing disk as well. So perhaps I deleted a machine, but I left behind a virtual hard disk that I want to attach to this machine. I could do that there. If I wanted to just go ahead and create a second disk, And here you can see I can choose my disk type. So if I want to use a different type to the one I used for the primary disk. So remember right now I've got that OS disk that's on premium SSD. I also have that temporary disk that's on a local disk associated with the host that the virtual machine runs on. So that has specific use cases where I want fast access to a locally cached disk. And then this disk, again, I can choose SSD, premium, standard SSD, or standard HDD. In my case, I'm just going to choose a standard HDD right now. Choose the name of that disk. That's the Azure name for the disk, not the name inside of Windows. The size, and then the source type. If I want to choose a snapshot or a blob that I already have of a VHD, I can do that. But in my case, this is just going to be an empty disk that I attach with this virtual machine. With that, I click OK, and then we scroll down a little bit further. And then I can move on to advanced pieces as well. So if I want to use manage disks, the default now is yes, that's what we always recommend. But if I wanted to manage the disks myself, I could choose no there if I wanted to. Next, we move on to networking. And in networking, first of all, you're going to see details around the network interface. So when you create a virtual machine, a network interface card is created for you and is associated with the virtual machine. I choose my virtual network that I want to connect this virtual machine to. So again, I could create a new virtual network or just connect it to a virtual network I already have. In your enterprise, you'll probably have a scheme of networks and subnets that you want to utilize. Choose the subnet. In my case, I just have the 10.0.0.0/24 subnet that I'm going to use, and whether or not I want to create that public IP. So I can click here. By default, it will prompt to create it, but I could choose none if I don't want the public IP. So perhaps I'm connecting through my VPN or express route from my data center that I have. Then I wouldn't need a public IP to access the machine, or perhaps I'm using a point-to-site VPN connection to get into the virtual network in Azure. Again, I wouldn't need a public IP, but in my case, I want a public IP so that I can just RDP into it, because this is an isolated Azure environment and I'm not connected in via any VPN or express route connection. Then we come across NIC network security group. So again, on a subnet, I can have my network security group, and I could just rely on the rules there, but I could also have a network security group associated with the network interface card of the virtual machine itself. Now I can choose not to. If I choose none, you can see that it says all ports in this virtual machine may be exposed to the public internet. This is a security risk. So obviously I highly recommend you at least choose a basic one and then choose which ports you want there. Or you can choose an advanced one. It takes away that basic option for you there, but you would then configure that network security group more specific to the rules that you want. In my case, I'm going to choose basic. I'm going to choose allow selected ports and select RDP as we previously did. Next, we have an option of accelerated networking. Now, accelerated networking is only available on certain instance types and certain operating system versions. So perhaps you've got Red Hat 7.4 and you wanted accelerated networking. That is available on that machine on specific D-series versions of the instance type. And that allows faster networking between virtual machines that have accelerated networking enabled. Essentially, it bypasses one of the virtualization layers and goes directly to the NIC card and just gives better throughput all around. So that's when you would use accelerated networking. Next, we have load balancing. So if we want to, we can place this virtual machine in the backend pool of an existing load balancing solution. In our case right now, we're not looking to do that or load balance this with other virtual machines. So we will move on to the management section. So under management, you can see here we have a few things. First of all, we have boot diagnostics, so we can opt to turn these on or off, and generally we just keep them on because it helps us diagnose any problems in the virtual machine. We have OS guest diagnostics. If you covered the monitoring section earlier on in the course or in some of the other videos we have, this is where you can turn on those guest level metrics, or you can just keep them off and just rely on the host level metrics from Azure. And the diagnostic storage account, which is where the diagnostic logs associated with those two things are going to be stored. It will create one for you if you don't specify one. For identity, as will be covered later on in identity, you can assign a system managed identity, automatically for you. And then we have things like auto shutdown. So enabling auto shutdown is something I always recommend you do in your lab environment. Turn it on, choose the time, whatever time zone you're basically in. So in my case, I am in Central Time right now, so got to go back the other way. So let's go to Central Time, US and Canada, and at 7 p.m. this machine will basically shut off automatically, and that will save me costs in my lab, and I can choose to notify before shutdown or not if I want to. Next, we have backup itself. So one of the fantastic features about Azure is you have backup built in, and it's as simple as clicking Enable Backup, choosing your recovery services vault if you have one, or creating a new one right now, and choosing a backup policy. And there's already some of those already built in for you. So if you do want to back up your virtual machine, all production machines, you should have this turned on by default, especially if you aren't using some other third-party backup solution. But for purposes of the lab, I don't need to back up this machine, so I'm going to turn that off and then move on to guest config. Now, guest config is more focused around things like PowerShell DSC extensions, Chef, Puppet, etc. They're not something we're going to cover right now, but you will see them in a separate module in the course if you haven't done so already. So we're going to move on to tags. Tags are really just a way for us to organize our data. You've probably seen some tag-in demos already, but let's say I just wanted my cost center. In my case, my cost center is lab. I can use this point in time to go ahead and add various tags to my build. Finally, I can review and create, and this is great because it also gives us an option to download the template, and you'll see ARM templates and automation much later in the course, but you can download the template for use in your automation tools right here, before you go ahead and build it. But if you are happy with it, check through everything, make sure everything is as expected, and then go ahead and click create, and that will begin building your virtual machine. Windows machines, B series, take about 5 to 10 minutes to complete. If you choose a D series on premium disk, then they'll be created in much less time. And finally, Linux machines a little bit quicker as well. So plenty of options, but you can monitor your deployment here. You can cancel it, during deployment if you want to. You can see the services in Azure that have already deployed. You'll notice like the IP, the NSG, the disks are all separate services. You can watch them deploy there if you want to. You can also go and see the template on the left-hand side. You can still download it here if you want to. You can add it to your libraries if you want to redeploy, similar machines. This is a good way to kind of, create that ARM template and get it the way you want for deployment later, via automation. But with that, this concludes this demonstration, and in the subsequent demos, you will see how to connect to your Windows or Linux machines. With our virtual machine now deployed, it's now time for us to connect to the virtual machine itself, and there are multiple ways that we can do that. First of all, let's go over to the Azure portal and create an RDP session to the virtual machine. Here we are in the Azure portal, and the easiest way to find your VMs is either to click the Virtual Machines tab on the left or go into your resource group, but note that it will show the other associated features with the virtual machine as well. Here we are in the Virtual Machines tab, and you can see our virtual machine, SL-VM01, which is our Windows virtual machine here. Go ahead and click into that. On the right-hand side now, you'll see an icon that says Connect. Go ahead and click that one. As you can see, it will download an RDP file to your machine. If you open that up, it'll look just like a normal RDP file that would use when you create an RDP connection to any Windows machine traditionally on your on-premises network. You'll get a certificate warning. That's just because we haven't created a certificate for this machine, but go ahead and click Connect, and you'll be prompted for your credentials. Now just simply enter the username and password that you used when you created the machine. Click Yes if you're prompted for the certificate warning again. And as you can see, we're connected into the machine, and up comes our desktop. So that's one way to connect into our virtual machine. The next way is very similar, but instead of us doing it through the portal itself, let's go and do the same thing using PowerShell. So first of all, let's close out of this RDP session and go over to our PowerShell client. And in this case, we use the following PowerShell command: get Azure RM remote desktop file, followed by the resource group name. In our case, it's SL-70533-VMs, followed by the name of the virtual machine. And then we can add an optional parameter either for launching it directly or saving it locally. In this case, we're going to launch it, hit enter, and you can see immediately we get the connection box pop up and we can go straight into our virtual machine. Alright, so we've seen a couple of methods to connect to our virtual machine via RDP, but it's also possible to connect via WinRM using PowerShell. In order to do this, we have two main methods: WinRM HTTPS This is where we can connect over SSL using port 5986, and this is the recommended option if you're going to connect over the internet, as it's much more secure. In addition, we have WinRM HTTP. No SSL is required. This uses port 5985, and this is ideal for connections from the same private network which is already secure. There are a number of steps involved in order to set up WinRM. First of all, you have to create a key vault, create a self-signed certificate, upload that certificate to your key vault, get the URL for your certificate from the key vault. So at this point, we've created the key vault, the certificate's in the key vault. Now we get the URL for the certificate directly from the key vault. Finally, we reference our self-signed certificate when we create the virtual machine. All of these procedures can be found at the following link. You won't be expected to know the detailed commands for this, but you should be familiar with the high-level procedures of what's required to create the self-signed certificate. And with that, that concludes this demonstration. Okay, so we know we need to plan for availability in Azure. How do we go about doing that? And the mechanism Microsoft uses for that are availability sets. Before we can decide how to use them, let's understand our potential for VM impact first. First of all, we have planned maintenance. This is when Microsoft needs to patch or say do some firmware upgrades on the underlying hardware that your VM is running on, and they need to evacuate your VM. In most cases, this will happen using their live migration technology. They will simply move your virtual machine from one host to another. But on other occasions, they do need to shut down your virtual machine in order to do this maintenance because live migration won't work for whatever reason, and so you need to account for that. The second one is unplanned hardware maintenance. This is when Microsoft detects, using say their monitoring systems, that a failure may be about to occur on the underlying host. And again, kind of like planned maintenance, they need to move your virtual machine, or sometimes very quickly they have to shut all the virtual machines down, do the maintenance, and then bring that host back up. And then finally, we have unexpected downtime. This is when there's a catastrophic failure to the underlying hardware, and you're essentially forced. Your VM is, shut down immediately, not gracefully, and the VM will eventually be powered on another machine, but your application will receive an outage. The way to solve this is using availability sets. This allows us to group two or more machines into a set, and they're basically separated out based on two things: fault domains and update domains. If we think of fault domains, first of all, this is essentially when we have a rack that has its own power, its own networking connectivity, and we can have up to 3 fault domains in an availability set. So if we think of our virtual machines, if we have 3 virtual machines in a particular tier, which we'll get into more in a moment, they can be spread out amongst those fault domains if we've used 3 fault domains. If there's an outage to one, the virtual machines on the other fault domains will be unaffected, and eventually the virtual machine that had the outage on the first fault domain would come back up once Microsoft resolves the underlying issue, or just simply moves your machine to another host. In addition, we have update domains. So think of these a little bit differently. Microsoft has to patch a whole series of hosts, but they will do them sequentially, and they won't patch the same update domains at the same time. Now, they allow you up to 20 update domains, so your virtual machines will be spread out amongst those update domains in your availability set. You don't control the specific order. So, for example, if you've got 3 update domains, UD0, UD1, UD2, we know that they won't happen at the same time. Again, this is the patching of the underlying hosts, not your virtual machine patches themselves. But we know that UD0 won't happen at the same time as UD2, but UD2 could happen before UD0. This isn't an ordering system, it's simply a separation. If we think of planning for availability in a little bit more detail, the other thing we need to think about is what goes into an availability set. Well, it's very important that you put your tiers into separate availability sets. Think of it like this: we would have an availability set for our web tier, an availability set for our app tier, and an availability set for our data tier. Now think of it just from a fault domain perspective. We know now in our web tier that if we had 3 fault domains, those 3 servers would be separated out between 3 underlying fault domains. The reason for this is if we combined everything, let's say we put our data tier and our app tier and our web tier all together, we could be in a situation where all of our data VMs are on the same fault domain, because again, we've only got 3 fault domains. Microsoft's going to spread all of those machines out amongst the fault domains and update domains as well, obviously. And if we've got too much in there grouped together, they could just, we could just have all of our data machines on the same fault domain, and that doesn't really help us from an availability standpoint. So use this model whenever you're trying to decide what availability sets to use. And there's definitely a lot of questions, at least when I did the exam on this. They'll give you some scenarios on, he has so many web servers, so many app servers, so many data servers. They'll describe the scenario, and you have to decide how you group the servers out. As we've covered availability sets, Microsoft has also begun to introduce availability zones throughout their regions. Now, they're not available in every region, so it is important to look at the regions when you are planning for availability zones and make sure they are available. But essentially, they work similar to availability sets, but now we get 99.99% availability. They minimize the impact of planned and unplanned downtime and really just enforce them like availability sets, but now you choose your specific zone in Azure. So in availability sets, we had those fault domains and update domains. What we do with availability zones is we essentially just choose the zone. In fact, when you build in your virtual machine, you'll get a number. If availability zones are available in your region, you'll get to choose those instead of availability sets. So it's a either or option. You can't have availability sets now in the regions that have zones. They want to move you towards zones, but essentially you choose the zone number. So if you build in a VM, one VM will go in availability zone 0, one will go in availability zone 1, and then that they're in separate data centers in the same region. Now, the latency is such that it's such a fast connection between the two data centers in the region itself, so there's no performance impact by using zones, but they do give much better redundancy. In fact, there was a region outage in South Central at one point where the data center essentially had some power issues and went down, and just because you're in an availability set did not help you. You were completely out. All the backup generators and things didn't kick in properly, and people had complete outages. But availability zones would be two data centers further enough apart to make sure that in the event of something like that happening, you would still be online, providing your machine was in the other availability zone. So know these in addition to availability sets. It's pretty much become impossible to talk about Azure these days without first understanding about app services as a whole and where they fit. As opposed to a virtual machine, app services allow us to bypass that layer of OS management and IaaS infrastructure management and shift that focus up to run in our applications. At its core, app services is a series of PaaS-based application services. So if you think about it, it consists of the following four. There are web apps, mobile apps, logic apps, and API apps, and all of these can run on the same underlying infrastructure of virtual machines that support them. So let's take a look at web apps in more detail. Well, web apps were formerly known as websites. If you're familiar with classic Azure, this is what we called them back then. And they allow us to host and build web applications using a variety of programming languages that we can choose from. They offer auto-scaling capabilities as well as high availability, and also include a whole bunch of DevOps features that enable us to automate deployments from things like GitHub, Visual Studio Team Services, and other sources as well. Then we have mobile apps, which also run on that underlying infrastructure, and they allow us to build a mobile device backend. Essentially gives the developers that mobile-friendly environment platform, still is highly scalable, highly available, and allows developers to build native apps for iOS, Android, Windows, and cross-core platform apps are supported as well. One of the biggest benefits, is really that this shares the same app service deployment to reduce those run rates and bring the costs down. Then we have one of my personal favorites, which are logic apps, and these really allow us to automate business processes. Think of it like creating your own orchestration workflows. There's an orchestration engine under the covers that helps us out with various tasks that we want to perform. And think of these examples like, every time your app calls an API, I want to do some task, or every time there's some data in blob storage, I want to do some work on that, or maybe there's an external SaaS service I want to connect to. Perhaps I'm trying to do something more around the social media space, like check-in tweets or check-in Slack messages, and then I want to take some series of actions. So it's a very easy way to build automated workflows without really having to learn a lot of code. Then we have API apps as well, and so these allow us to easily create, consume, call APIs. We can basically use our own APIs as part of these, and these could also be from external API services as well. So then we get on some of the security features, and Azure App Services are highly secured. Any of the app service features that you consume will run on their own isolated virtual machine. They meet all the security standards, so ISO, SOC, PCI compliant, all the main ones are there. And Azure Active Directory is fully integrated as well, so it can be used to authenticate users along with social logins. And in addition, Microsoft recently added managed service identities, which are currently in preview, but a managed service identity from Azure Active Directory allows your app to easily access other AAD protected resources such as Azure Key Vault. The other things that are really important are some of the features that are supported from a security standpoint are custom domains, SSL TLS, custom certificates that includes wildcard or subject alternate name, supports multiple directory authentication protocols, so OAuth, OpenID, and Microsoft Active Directory. And finally, this is really important, with the release of Web Application Firewall, this can be integrated into your web apps and app services as well. So then we have DevOps features. Pretty much, you can't release a good development platform without having a lot of DevOps features. So Microsoft includes the most common ones here for you. So, CI/CD support is available through Git, GitHub, Bitbucket, Docker Hub, as well as VSTS as well. You can integrate with all your popular IDE tools such as Visual Studio. That could be the Community Edition, could be Visual Studio Code. That's all available for you there. And it also supports deployment from external folder sources such as Dropbox and OneDrive as well. So if you just want to get your application up that method, you can do that as well. App Service also has a unique feature called deployment slots, which allow us to stage environments. So we can basically have like a stage environment, a prod environment. We can deploy the stage and then flip it into prod, and you'll hear more about that later on in the course. So if we look at app service plans now in a little bit more detail, app service plans represent the collection of physical resources under the covers that are going to host our apps. This is where our apps are going to run on top of. So first we have to define the following: the subscription the plan belongs to, the location, so it could be like North Central US, the pricing tier, so it could be free, shared, basic, standard, premium, or isolated, and we'll talk more about that one shortly. And the instance size, so this is the size of the VMs running under the covers, and you'll notice when you look at the pricing of these, they pretty much map to the VM sizes if you went and deployed a VM like you would just for IaaS. Once you've got that part set up, then you configure your settings. So it's around things like scale count, like how many instances do I want under the covers, what are my scale rules, allow for auto scaling if the plan supports it, scale up, you can increase the resources associated with the app service plan. This is essentially how you would switch the plan you defined at the start if you wanted to kind of increase the resources associated with it. So let's look at the pricing tiers in a little bit more detail. So first of all, we've got those shared tiers, the free and the shared one. So these run apps on the same Azure VM as other app service apps, and this includes apps of other customers. So here CPU quotas are allocated to each app that runs on the shared resources, and resources are not able to be scaled out. You'll need one of the other plans for that. And that brings us onto these, which are dedicated compute resource plans. So you've got the basic, standard, premium, and there's a premium V2 tier. These run your apps on dedicated Azure VMs, so only apps in the same app service plan share the same compute resources. The higher the tier, the more VM instances are available for you to scale out. And then we've got this isolated tier, also known as app service environments, and this tier runs dedicated Azure VMs on dedicated Azure virtual networks. So they provide additional network isolation on top of compute isolation for your apps as well, and these provide the maximum scale out capabilities for you. So there's some general guidelines that you need to follow. And first of all, you can select this link at the bottom, which will give you the subscription service limits and give you more details on that. But if we look at some of the guidelines in more detail, first of all, you create an app service plan for your specific applications. Then you deploy your app services to support that entire application. What you don't want to do is use a single plan for every single web app that you have. That's not going to scale very well, and it's just going to be very hard to manage. You do want to then combine app services versus mass VM creation as well. So this is a key thing, because if I'm going to go and create a whole bunch of app service plans and then put a whole bunch of app services then and spread them out. That's not going to be very cost effective. So the more I can combine my app services for that application, the better, more cost effective it's going to be. And then you can combine other services in the same resource group. So you can mix your app service plan. If you say you got, IaaS SQL servers, but you want to have web apps running in an app service plan, you can do that in the same resource group, so everything can still share the same life cycle. If you destroy the resource group, it could destroy everything, the IaaS services, the app services, plus whatever other services you've decided to utilize in Azure as well. Now, to wrap up, let's take a look at ASEs and app service environments and kind of talk through those in a little bit more detail. So app service environments, again, are that fully isolated environment. So it's a feature of Azure App Services that allows us to reserve that dedicated compute environment for securely running those apps at high scale. And ASEs can host web apps, mobile apps, API apps, as well as Azure functions on top of them. So your use cases really are around high performing apps, high CPU, high memory. Service instances are generally good enough, but they are pulled from a common pool which is shared with other Azure customers. At very high utilization, this could result in some performance problems, as compute services are all suddenly requested from a whole host of people. Within that, though, you've still got individual or multiple service plans that you can put on top of your ASE. So there could be a mixture of different plans that share different applications. And there are two ways we can go about deploying them, internal or external. So when we look at an internal ASE, this is where a VIP is created on an internal IP address. The internal endpoint is essentially an internal Azure load balancer. These are sometimes referred to as ILB ASE. And then you've got external ASE. Use this option when you want your ASE to be directly accessible via the internet. After selecting your VNet, you then select a number of external IP addresses you want to utilize. Again, something to stress here, this is created in a subnet of a VNet which achieves isolation. And another note, these may take a few hours to spin up. These aren't things that are just click of the button and readily accessible. They are reserving compute specifically for you. It's dedicated for you. So there is a time period as these spin up. So with all of that, this concludes this part of the module and hopefully gives you the good background on everything you need to know about app service plans. Make sure you understand the different plans, the different tiers, the app service environment option, the fact is that internal and external option, and I encourage you to just check out the upcoming demo which will guide you through creating your first app service plan in Azure. In this demonstration, we're now going to go about creating our first app service plan in the Azure portal, and we'll use this to deploy our web apps on top of later on. So let's head over to the Azure portal. Okay, and in the Azure portal on the top left, simply select create a resource, type in app service plan, and you'll see it come up. Simply select it once it's there, and that will give you the option to create the app service plan. Go ahead and click create. And now we need to enter our details. So first of all, what's the name of our app service plan? I'm going to use SL-app service plan as my example. Select our subscription. I'm going to use my pay-as-you-go one, and I'm going to create a new resource group to put all of these objects in. So call this one SL-app services. Choose your operating system that your web apps that you're going to put on top are going to run on. So if you're doing .NET apps for Windows, you would use Windows. If you're doing some kind of Linux-based apps, you would choose Linux as your operating system, and then select your location. So in my case, I'm going to use Central US, and then choose pricing tier. Now this brings us up to a good point. If we go over to our web browser and pull up app service plans on the Microsoft site, and if we scroll down, this is where you need to understand all the differences between the app service plans, and you can see Linux is called out specifically under app service Linux there as well. So if we look at these, we've got free, shared, basic, standard, premium, and isolated, as we mentioned in the tutorial section. So some of the key things we need to remember as we look through these. So first of all, there are limits on the number of apps you can deploy in free and shared. So it's 10 for free, 100 for shared. There are disk space limits as well, so 1 gig for those shared tiers. Then as we get up to basic, it's 10 gig, standard 50 gig, 250 gig in premium, and then 1 terabyte in isolated. And then we also have a max number of instances. So you may get questions on this on the exam, and you can see there under basic we can go up to 3, standard up to 10, premium jumps us to 20, and then isolated is 100. If we scroll further down, you'll see some other things like deployment slots are only available when you get up to the standard tier and higher. Development tools, everything's pretty much there, but things like cloning apps are reserved for premium and isolated, as well as some of the testing and production options. Those are for standard, premium, isolated, and app service for Linux as well. Most of the diagnostics and monitoring tools are there throughout, just some exceptions for app service Linux. And then for networking, you'll see there as well. If we want VNet integration, we have to be at standard, premium, or the dedicated isolated tier as well. For programming languages, if we drop down, pretty much good across the board there. You'll see though the difference between what you can deploy on top of app service for Linux and the generic Windows app services there as well, so that's important to be aware of. The one extra one you get there is Ruby on Linux, which you can't do on the Windows systems. And then as far as scale goes, that's the other important thing. You can see that auto scaling is only supported on standard or higher, as well as traffic manager is only supported on standard, premium, and isolated as well. So just be aware of this matrix. I think I've covered the major ones you'll get asked on the exam there. The big one that you'll see is probably around scaling and the sizes that you can scale up and down. There's definitely a lot of questions on those. So with that, let's jump back to our portal and go ahead and select a tier. So if we'll scroll down, and you can see there that these represent the price of the underlying infrastructure. So if I go ahead and select a standard, this is a 2-core, 3.5 gig of RAM, I've got that 50 gig of storage. I can scale up to 10 instances there, so you get a good summary there, and I get 5 deployment slots. So if I select that one, hit select, and then go ahead and click create, that will now spin up that app service plan, and should take probably a minute or two for that to be available. So we'll fast forward while that completes. Okay, and we can see in our notifications that deployment succeeded, so we'll go ahead and select that resource. That should take us directly to our app service plan. Take away these notifications, and we can see an overview there. We can see it's obviously not very much in use right now. The CPU percentage is low, but you've got this kind of good monitoring overview of your app service plan right at the front of the main screen. We can see that it's in Central US, status is ready, and then on the right hand side we don't have any apps deployed live or into any deployment slots at the moment. So with that concludes this demonstration, and let's move on to the next module where we'll start looking at deploying web apps themselves. In this demonstration, we're now going to look at creating and deploying our web apps to Azure. So we have our app service plan already created. Now we want to go ahead and deploy web applications into it. So let's start out first by deploying this from the portal. Okay, so in the Azure portal, let's select create a resource, and let's type in web, and then select web app from the drop down, and go ahead and click create. This will take us to the web app creation screen. So first thing we need to do is give it a name. So we'll call this one Skylines Portal, because we're going to do another one from Visual Studio in a moment. Select our subscription, so we'll use pay as you go, and I'm going to change the resource group. It does create a new one for you when you create in a web app, but I want to just put everything together in my SL-App Services resource group, so I can just delete everything at the end. And then I'm going to make this a Windows-based one, and then for my app service plan I can choose to create a new one, or I can simply select my existing one that I created in the previous demo. So we'll go ahead and choose that one. Finally, you do have an option to turn App Insights on. This is a monitoring technique, so if we wanted to get application insights similar to like New Relic and App Dynamics, tools like that, you can turn this on at this point as well, but we're not going to do that right now. So we'll go ahead and click create, and that will begin deploying our web app, and we'll just fast forward here until that completes. Okay, and that deployment succeeded, so we'll go to that resource. And we can see there Skylines Portal, and if we select this URL, you'll notice that they already put in a dummy website for us to kind of prove that the service is up and running. So we can see that that web app is deployed. So that's one way to deploy it, and we'll get into all the configuration settings a little bit later on. But what if we want to kind of do this from Visual Studio? What if we've got some code we actually want to deploy? So that's the other great thing. If we go to Visual Studio, and start off with a new project. So we'll create a brand new .NET application. So I'll hit new project and we'll choose web, we'll choose ASP.NET Core Web Application. We'll give this a name, we'll just call it Skylines Web App, and go ahead and select OK. That's going to create a skeleton web app for us. I'm going to select the defaults here. I'm going to use the model view controller model, the MVC model, and select OK. This is a pretty typical model for a lot of .NET developers. And then it goes ahead and creates everything there. If I want to just check this locally, first of all, I can go ahead and run that. So I'll hit debug and select start without debugging. So I'm not trying to do any kind of monitoring or anything at this point. And that will open up this application. Let's just take a look at it locally first of all before we push it up to Azure. So there we can see they've also given us a sample web page. So what we'll do is go ahead and click About, and we're going to add some information to the screen. So it says, yeah, use this area to provide additional information. We'll go back into Visual Studio. Let me close this out and go to the About section. So if we go into www root and look for, it might be under our controllers here. Yep, it's under our view, and go to About. And we can see there that your title is about. The message actually comes from the controller, but you can use this area to provide additional information. So we'll change this and we'll call this, Visual Studio Deploy. And we will go ahead and save that. And now we can go ahead and publish that to Azure. Now to do that, simply scroll back up on the right hand side, right click your web app and choose Publish. Select Start. And then we have the choice of creating new or selecting an existing. So if we select existing and go ahead and select Publish, yeah, you'll see we've got a subscription, and in our resource group view, if we expand this out, we can see Skylines Portal there. That's the one we deployed from the portal earlier on. But you can see we can deploy into this. We can deploy into deployment slots if we create one as well. We'll come back to that a little bit later on. But hit cancel. Let's go ahead and create new. So if I select create new, click publish, and then it'll ask me to create an app service, but I can choose my existing app service plan. So I can go ahead and select the one I've already got. So I can share both these web apps on the same plan, but I can give it a different name. So we'll call it Skylines Visual Studio, and that's that's going to work for us. Pay-as-you-go subscription, and in our resource group we want to use the SL App Services resource group as well. And then I'll go ahead and click create. Okay, and that's currently now publishing. It's created the web app on Azure, and now it's publishing, basically deploying directly into it. So we'll fast forward again here while that completes. Okay, everything completed successfully, and so now it's pulling up the website at skylinesvisualstudio.azurewebsites.net, and we can see that published successfully. Let's select the About page, and we can see that Visual Studio Deploy is there. And so that's it. We'll jump back to the portal very quickly just to show you the app service plan. So if I go back to Home, go back to App Services on the left hand side, and you can see we've got Skylines Portal, Skylines Visual Studio, and both of them are using the same SL-App Service plan that we created in the first demo. And with that, that concludes this demonstration, and I hope that gives you an idea of the different ways you can create web apps either from the portal or from Visual Studio. You can certainly do it via command line as well, but these are very common ways to get things done. Now that you have a good understanding